what we can do here now is that we can shorten the approach and basically have less track miles during the approach, and that's where you can see the fuel saving benefit in addition to the continuous descent approach. And if you combine these, the overall result will be optimum, I would say. Yeah. We've done a curved flight path during the latter part of the approach compared to a standard arrival where we usually fly a straight track towards runway. The flights we've been conducting here in the project compared to the normalized figures, compared to how we used to fly, we're talking about roughly metric ton of CO2 savings per approach. So there is a tremendous saving potential in implementing this new performance-based technology in Sweden, but also in Europe, of course, overall.
Basically, it's taking a pilot view of the way air transport is managed and air traffic management is functioning. It is looking at the trajectory going from A to B, and everyone sharing a same view of where the aircraft is going and making decisions together on the same level of information.
If you can perform an optimum profile, generating a minimum amount of noise in the latter part and of course a lower fuel consumption, that is satisfying, of course.
Tomorrow everyone will be involved in the optimization of a whole trajectory from A to B instead of just segments.
The real thing is minimum CO2 in the terminal area. What it's all about is to have the least possible pollution in the terminal area, and that's both for CO2 and for noise. We have these systems on board, and this is state-of-the-art aircraft that we're talking about, but this type of equipment is available in any aircraft that's leaving the production line in Seattle or in Toulouse. And what we showed here was the optimum use of this capability. With this approach, that when we came from the north, we have the largest track mile savings. And we are somewhere around 300 kilos, which is about a metric ton of CO2. And on top of that, we have the noise. And the noise level is very low when you're able to operate like this. The pilot didn't have his foot on the gas pedal or his hands on the throttle until we were down to about 300 meters. And there he throttled up a little bit. And we did a very soft and nice landing on top of it. So it was a very good experience.
It's a great possibility to reduce noise. I see noise because in the near the airports, the noise is almost the biggest thing for the people who's living there, to reduce noise, and then you can reduce the carbon dioxide emissions as well. I think it's a great potential.
So today's flight showed LFV that we have our industrial partners is there, our airline partners, the airport partners, and also the European like SESAR. It is coming together. We deliberately said to ourselves that we're going to be active in this area, and this paid off today on today's flight in that sense.
I feel very happy about today's flight. We were able to demonstrate all the different elements that we intended to do. We did this continuous descent approach, which is a bit like driving a car and you're coming to a hill and you step off the throttle and you just roll down, burning minimum fuel. We did that by uplinking these winds that are into the computer of the flight management system that really optimize things. We set a time, an arrival time. We were 2 seconds within that arrival time, and we were able to fly a very efficient RMP approach, demonstrating this capabilities.
Typically what has happened here today, which is a good example for people to look after, so that we can zoom into this and say, this has worked. Here we have an environmental case. It was demonstrated today. Why not bringing it from Stockholm elsewhere in the world and fostering the type of partnerships we have fostered here? SESAR is about doing this at a larger scale because the constraints that are facing Stockholm are also the constraints that are faced by other airports in Europe. So deploying best practice and accelerating the pace of change through industry lead and partnership is what SESAR is all about, by incremental steps, not with a big bang type of approach. We want things to happen faster rather than later.
The passengers will benefit of shorter flight times, because in the future here we will be able to have this 4D operation in effect, and basically what that is all about is that if you're flying into a big airport, London for instance, you usually end up in a holding stack there, all right? But the thing is, in the future concept of operations, we will take the delay at the departure airport. So when you're arriving towards the London area, you will make a CDA approach and go straight in for landing.
From a passenger perspective, we are really talking about basically spending less time in the air and having much more predictable punctual systems, whilst the environmental impact of transporting will be going down. This will be then repercuted to the airlines, that ultimately will have a much more stable operation, more environmentally friendly operation, and be able to continue to grow, because as you saw, there are capacity challenges the industry is facing.
Safety is the priority number one for the whole system and everyone that operates in the system. We are currently using navigation systems and aids that are developed from the 50s and forward. So we're going from a system where we have computers in the air, we have computers in the ground, and they don't speak to each other, to a system where we're optimizing using the resources we have.
Overall, then also the system will be becoming safer, because as the information reference will be shared by everyone and decisions will be taken together, everyone will be much more comfortable about taking decisions, also from a safety perspective.
First thing, I was very impressed with the amount of work that has gone today into this demonstration. There was obviously a lot of foresight, a lot of thought, multiple levels of benefits that are derived for our industry. I was very pleased to see that safety is still the primary consideration, and after that we get into the environmental and the economic factors.
Climate change is a global problem requiring global solutions. More and more countries and actors are also recognizing the importance of taking action. This will increase the demand for new solutions and new technology. This demand also opens new business opportunities. Countries and companies that are in the front line today will be the winners of tomorrow's markets.
Environment is really a key issue now, and we are putting a lot of resources, be it in biofuels, be it in aerodynamics, be it in new engines, and be it also in air traffic management, because all that will shape the future of our industry.
There's a shift in some of the priorities in the States as well, a little more awareness in the environmental issues as they fit hand in glove with the economic issues. So it's a win-win all the way around when we can address those.
Events like this one will, show the world that this is feasible, even if it's today with one flight or 10 flights, and tomorrow in more busy areas. I'm sure we will see that happening probably sooner than we think, because we will be pressed by the community for environmental reasons, which are, I think, good moral reasons.
And the progress the community has made since 2 years are, to be frank, are tremendous. We were not expecting such progress in air traffic management, and now things, if I may say so, are going faster and faster, and that's good news for everybody.
Well, I think from an air traffic point of view perspective, to have a safe separation and a flow of traffic is our key business. So we are entering sort of a little bit of a change towards more managing the airspace, letting the airplane fly according to its own optimum routes, and we are monitoring and guiding it in order to do that. It is going away from the current where we are more active control to more monitoring.